So we're just picking up right where we left off, solving inequalities, as you can see from the top here. Just reminding you that, or giving you a heads up, these notes are about when we have special cases, right? No solution or infinitely many solutions, very similar to equations, right? But we're now on inequalities, still using the same LDCMAM. The only difference is if I multiply or divide by a negative number, then I have to flip that symbol. So L, right, is for the line you draw down. D is for distribute, no distributing here, but C is for combine like terms. Remember, you look at the left side, no like terms. Look at the right side, there is some like terms. So I'm going to bring down the left side, 8 plus 6x. Here, 7x minus 1x is 6x plus 2. A common theme you'll notice in special case equations or inequalities is the variables end up being the same on both sides, which is why they end up zeroing out, right? So if you subtract 6x, it's going to zero out on both sides. And on one side you'll have 8. Your symbol here is greater than or equal to. And on the right side you have a 2. And here's where you for one, you have a special case, right? No solution or infinitely many solutions because the variable's all zeroed out. But which one is it, right? Well, 8 is greater than or equal to 2. That is true, you guys. 8 is definitely greater than 2. Since it's true, we can read up here. If it's true, we have infinitely many solutions or all real numbers. So I'm just going to put A, R, N for this one. And move on to the next one. So in this one, let's see, we have very similar to the last one. We have like terms here. Wait, don't forget that line. No like terms on the other side, no distributing. Bring down 6m minus 5, that's greater than 7m minus m is 6m plus 7. Once again, on this one, when I subtract 6m on both sides, the variables all zero out. And I have negative 5 still on the left side, I have 7 on the right, and this says, so make sure you know how to read your symbols, have some notes handy if needed. This says negative 5 is greater than 7, and negative 5, that's false. Negative 5 isn't greater than 7, so if the result is never true, if the result is false, right, we have no solution. So on this one, we have no solution, remember. With no solution, we could just do this, right? We could put a little symbol. Remember what these mean, right? You guys, you could take any number, right? On this one, you could take any number at all. 2, 3, negative 5, a million, negative 50, and plug in for x. And what you'll end up with is a true statement at the end. So no matter what number you plug in here, it'll always be true on both sides. Now this one's the opposite, right? No solution means no matter what number we plug in, we will never get a true statement out of this one. So I'm going to move along, still following my steps. L, D, C, M, A, M. L for the line. D for distribute. This one does have distributing on the right, doesn't have any on the left. So 10 minus 8a comes down. On this side, let's make sure we multiply, right? 2 times 5 is 10, and don't forget to multiply 2 times 4 also, so minus 8a. I'm going to add 8a to both sides to move my variables together. And when I do that, as with all these special case problems, the variables zero out. And I have this statement, 10 is left on both sides, and it says 10 is greater than or equal to 10. This is true, you guys, because 10 does equal 10. So since this one's true, I'm going to answer all real numbers. Again, true, because 10 does equal 10. So all real numbers, again, what that means is any number you plug in here for A, you'll always get a true statement. You'll always get a number on this side that's greater than or equal to the number on the right. So moving along on this next one, there's no, if you draw that line in, there's no distributing or combining like terms on the left, no distributing or combining like terms on the right. So my first step on this one is going to be to move the variables together, subtract 5n both sides. As what has been happening, variables zero out. I have 9 on the left side, less than or equal to negative 1, And is 9 less than negative 1? Nope. Does it equal negative 1? Nope. This is false. So we're going to answer no solution, right? If it's false, no solution. Whatever number you try to plug in, I'll never get a true statement out of that one. These last couple, let's see here. Draw this line in. On my left side, negative 5r plus 6, nothing to do there, no distributing or like terms. On the right side, negative 5 times r, right? We definitely need to distribute. And negative 5 times negative 2 is going to be positive 10. Bring down the negative 5r plus 6 on the left side. Add 5r to both sides, right? To get your variables together, add 5r to both sides and end up with 6 here on the left is less than or equal to 10. And then I gotta ask myself, is 6 less than 10? Yeah, 6 is less than 10. This is a true statement. So since it's true, all real numbers, right? This one has infinitely many solutions, so all real numbers. Or you could put IMS for infinitely many solutions. And this one here, let's draw that line down from the, separate the left and right side. On the left side, there's no distributing or combined like terms. On the right side, I can see that distributing needs to happen. So bring down the 9 plus 2x. Over here, 7 plus 2 times x is 2x, and 2 times the negative 3 is minus 6. Combine like terms, 7 minus 6. Just bring down the 9 plus 2x on the left. 7 minus 6 is 1, so 1 plus, bring down the 2x. Now I'm going to subtract 2x to move the variables together. And again, special case, right? They zero out. And I have this statement here, 9 is less than 1. Again, I would ask myself, is 9 less than 1? No, it's not. This is false. No solution.